Alright, so hello and welcome. Let's build a very simple app telling us which of all available assets on Binance are currently, so in this exact moment, are fulfilling the condition of a simple moving average crossover. So let me quickly show you what I'm talking about. If I click this button, I'm getting the feedback which asset is crossing over right now. Can be a lot of assets, but also can be no asset. So let's actually do that. And going to Binance to kind of prove that this is actually working. So let's pick Atom. So you see we have the crossover here. Or I don't know, near USDT, you have the crossover here. All right. So let's move on to some prerequisites you need and the infrastructure to build this. But before doing that, if you find this interesting, please leave it a like, subscribe, and then we can extend this platform, improve the code a bit, and so on. If you've followed some of my previous videos, try to build it on your own before you're proceeding watching this and see if you can manage to do it yourself. Alright, so let's take a look at the prerequisites. So you should be able to connect to a Websocket or Binance Socket Manager live stream. We will actually do that in this video. I'm just not getting much into details here. You should be able to run Streamlit apps and have some basic idea about Streamlit functionalities. Also, my video on SMA might be helpful, so especially the newer one. And also you should be able to connect Python with a SQLite database. I've covered all those topics beforehand in other videos. Everything is linked in the video description. So let's take a look at the infrastructure. So the first script is populating a SQL database with live prices of all available Binance assets. And the second script then is calculating SMA crossovers and connects to Streamlit. Important disclaimer, my videos should never be seen as investment advice. Technical indicators are no guarantee for profitable trades, and cryptocurrencies are not regulated. Okay, so let's start with the first script. By the way, this is very similar to my previous cloud deployed crypto bot. So please check that out. I'm not going that much into details here. So we need pandas for data handling. We need Websocket and JSON to transform the message received from the WebSocket to a Python dictionary. And we also need to connect to a SQLite database. So we are using SQL Alchemy for that, importing create engine, and then define our engine as create engine and then give it a name. So we are using a SQLite database here, and then just give it any name. So I'm using the name we used before, so just cryptodb.db. Now we are defining a stream and we are using the mini ticker stream. So this is a stream which is just providing us a rolling 24-hour price of all available cryptocurrencies on Binance. Right, so the open price is the price 24 hours ago and the close price is the price as of now. Okay, so we need the link to do that. I'm just copy pasting that from my other stream. So as said, this is the exact same stream as we were using in the cloud deployed crypto bot. Okay, so with that we are getting all prices for all available coins. And now we are starting a WebSocket stream and define what has to be done with the received message. So I'm just taking the notation from the official WebSocket documentation. So using VS or WS, and the message, then define our message by using JSON loads to transform the string formatted message into a Python dictionary. Once we got that, I'm just filtering out all symbols which are in relation to the US dollar or the other way around. So I'm filtering for only those symbols which are in relation to the US dollar Tether. So I mean, you can also work with currency pairs, right? So for example, Binance coin or BNB in relation to Bitcoin, I'm filtering them out here. So I'm just using symbol and then use a list comprehension. As said, this is the exact same as we were using in the cloud about here. X for X in message, if this X symbol ends with USDT. Alright, so with that we have only those assets which are in relation to the US dollar stablecoin. Now we are wrapping that all into a data frame using the data frame function from pandas, provide our symbol list here, and we have just filtering for the timestamp, which is E, S, which is the symbol, and C, which is the close price, so the real-time price if we're using a mini ticker stream here. Also, we are transforming this Unix timestamp into a human readable timestamp. So we're using PD to datetime, provide the event timestamp column, and then define the unit as MS. Also, we are transforming the close column containing our live price, which is currently a string value, just as a floating value. So we can make calculations with that. Finally, we are just looping over all rows of this created frame, and we are writing every row to a SQLite database. All right, so every row is containing a certain cryptocurrency pair, and we want to have a table for every cryptocurrency pair. So I'm just using a loop for that, for row in, and then the range of the length of the frame. And then we are defining our data as frame, row plus 1. So this is just taking every row of this data frame containing all available rows for a tick provided in the minute ticker stream. As said, more detailed explanations in my cloud deployed CryptoBot on how this is working. I'm actually printing out all the stuff so you understand what is actually happening here. Okay, now I'm just writing the timestamp column and the price column to a SQLite database using ToSQL. Give the table a name, so I'm just using the symbol column for that and access the actual string value. So that could be, for example, BTC USDT. Provide the engine we have defined above here and set the index to false. And if this table already exists, I want to append this. Yeah, and that's already it. So of course we have to start the Websocket here. So we're using WS Websocket app, provide our stream, and then we want to tell the WebSocket what is happening when we receive a message, and we are just calling our previously defined function on message. Okay, and we want to run this forever. And with that, we are populating our database, Crypto DB. Okay, so let's move on with the second script. Important to note here is, as you see, I'm using an IPYNB or Jupyter Notebook file, but you have to transfer this into a raw Python file to be able to execute it with Streamlit. Right, so I'm just using that for presentation reasons here. So first of all, we need to import Streamlit. Then we need pandas for data handling. Datetime, we need to get the current time, but in the Binance time zone. Then we need NumPy for a conditional check. Now we are connecting to our database we have created in the first script. It's just the same syntax, so import create engine, and then define the engine as create engine SQLite, and then cryptodb.db. Now we are pulling all available symbols out of the CryptoDB database, and we are doing that with a SQLite specific syntax where we are just pulling all available tables from this database. So I'm storing that in a list here, or in a variable symbols, and use pd read SQL to execute SQL syntax, and then take select name from SQLite master where the type is a table. Provide our engine, and with that I'm quickly showing you that I'm getting a data frame like this containing all available symbols here. I'm accessing this name column here and transform that to a list, and with that I have a list containing all available symbols. Alright, now let's give that a title. So welcome to the live TA platform. This is optional, you can call it whatever you like here, right? So I'm not executing that right now. This is only important when we are running this script as a raw Python file as said with Streamlit. Now we are getting into the calculation part of technical indicators. And first of all, I'm just adding two columns, one containing the short-term simple moving average, one containing the long-term simple moving average. And I'm creating a function for that, so I'm calling that apply technicals. This is taking a data frame as an argument and is adding a column SMA7 to that. And this is just rolling over the C column containing the live price with a 7 time steps window, and then taking the mean. So this is just the formula for a simple moving average. Same for the long-term simple moving average. So of course you can add those parameters here as arguments for this function. A lot of improvement potential as always. In case you're wondering, okay, why 7 and why 25 days? Sorry, not days, but time steps. It's just due to the fact that Binance is using those indicators. And to be able to check if what you're doing is actually right, you can just use the Binance parameters and check if there is a crossover on Binance, if your script is telling you there is a crossover. Alright, so last but not least, we are just dropping all NaN values, which are occurring due to the rolling function. The objective of the next function is to query price data from the database over the last 30 minutes, just slightly above the long-term simple moving average time horizon. The function is also implementing our apply technicals function on the pulled data. But before that, we have to resample the currently roughly on a second sampled data to 1 minute sampled data. So let's do that. Let's just call the function query, and this is taking a certain symbol as an argument, for example, Bitcoin USDT. First step is to get the time of now. And as the Binance servers are in the UTC time zone, we are just taking daytime and then UTC now. Right, because you could be in another time zone than the Binance server. So for example, I am in another time zone. So I have to use this UTC now instead of just now timestamp. Now I'm just going 30 minutes back as said. So now minus DT time delta minutes 30. And now I'm just creating a SQL query which is pulling price data starting from now until 30 minutes back. So I'm using an F string to achieve that. Select the timestamp column and the price column from the provided symbol where the timestamp is larger than or larger or equal to before. All right, and then we are wrapping that all to a data frame using read SQL, provide the query string and the engine. So just to make it more clear, let's quickly take a look at what we would get. So if I'm providing the Bitcoin here, I have a typo here. date time, of course. And then we're getting a data frame like this, right? Timestamp here, close price here. And what I was referring to, we have second sample data, right? You see that here. So if we would calculate a simple moving average now, we would calculate it over 7 seconds. So we have to resample this data frame to a minute sampled data frame. So that would be the next steps here. So first of all, we have to transform the timestamp column to a datetime column, because currently it's a string column. And then we are setting the index of this data frame to the timestamp. And this, so why am I doing this? To just resample the data on a 1 minute time frame. So we are just using df resample, provide the period we want to resample that on, and we want to take 1 minute here. And then I'm just taking the last price here, right? So let's actually execute that again and call that again so you understand what's going on here. So now we see that we're getting the last price of the minute here, right? So you see this is the most recent price here, right? So if I would update that, I would get another price here, right? Let's do it again, 1512 here. What do we have now? 48438. 48439, right? So this is the most recent price, and then we have the prices the minutes before. All right. And now on this one, we are applying our technicals. Okay, so we're just taking apply technicals and provide the data frame, right? So let's do it again, query BTC USDT, and we're getting the short-term moving average over 7 and 25 minutes here, all right? And finally, I'm just adding another column here, which is checking if the short-term moving average is above the long-term moving average. So why am I doing that? Because I want to know when the crossover is happening. And if the short-term moving average is above the long-term moving average, and it was the minute before, there is no crossover. But if it wasn't the case the minute before, there would be a crossover, right? So I'm adding a column here, position, and I'm just using a conditional check here in NumPy where this this short-term simple moving average is above the long-term simple moving average. And if that's the case, I want to have 1. If not, I want to have a 0. So let's check it once again. And now this is a good example. So it is the case that the short term is above the long term here, but we wouldn't get a crossover signal here as the minute before it was also above this long-term moving average, all right? So, and this is where we need the next function for, which is just a check function if that is the case, what I just described to you. So we have a crossover in the most recent row, but we don't have in the row before. So we are creating a function check. This is just looping over all symbols for symbol and symbols. And now it's just checking. First of all, we need a check to avoid empty data frames. So if length of query of a symbol, then the position column is larger than 1. So why 1 and not 0? Because we need at least 2 rows here, right? To make this check possible. So last row and the row before. And then we are just checking what I explained to you. So symbol, position, and then the very last row, so the most recent one. If that is a 1, so we can just keep it like so. If that is 1, and the row before is 0, so we can just check that by using a diff function. So, but let me quickly show you how this is working. So BTC USDT. So a diff function is just taking the difference between two rows. So for example, if 1 minus 1 is 0, we wouldn't have a crossover here, right? Because 1 minus 0, so here's a 0 and we have a 1 here, this would be a crossover. Then the difference would be 1 minus 0 and then we have a 1. So we need those two conditions. First of all, the last row should have a 1, and the difference of the last row and the row before should be 1 as well, because this is only the case if we have a 1 here and a 0 here, right? So we can just check symbol position diff of the very last row. Okay. So let me show you. I think it's quite difficult to understand. So you see it like this, right? So here in the very last row, which I'm indexing here, we have a 0, right? So we cannot have a crossover here. All right. Okay, and if that's the case, we want to use Streamlit and write this symbol where the crossover is happening. All right. And finally, we want to have this button. So we're using st button, give it a name, get live SMA cross. And now we are using on click, and then we are calling this check function. So whenever we are clicking the button, we are doing all this stuff on all Binance assets, which are being feeded to our live database. All right. And finally, we just have to download this script. By the way, you can do that. I have to zoom out a bit. You can do that here, and then just execute this file via Streamlit. So let's actually do that together. I'm downloading it now, and then I'm executing that via Streamlit. All right, so let's run it. So I've downloaded the file as a raw Python file, then named it to check.sma.py, and then I was pulling the file in my current Python folder or my Anaconda environment folder, which is just my home folder. And then I'm using Streamlit run check.sma.py. You can also run this in your terminal without this exclamation mark here. So let's run this. And now you see we have the platform you see or you saw in the beginning. And yeah, that's it. So thank you very much for watching. Appreciate it. Let me know what you would be interested in the comments below. Let me know your thoughts. And yeah, I'm looking forward to seeing the upcoming videos. Bye bye.